I guess that's how your eyes work.
Say it again?
That's how your eyes work.
Without the mirror.
Yeah, but you have mirrors in back of your eyes. Your lens. You have lenses in your eyes.
Yeah, the thin lenses,
Yeah.
it's a similar derivation with thin
Yeah.
lenses, but we're a little bit different here. All right, so let's take a look at the other one. So I'm looking at this triangle. This is labeled as theta 1 and theta 1. So the tangent of theta 1, looking at this triangle right here, equals what?
Is
The opposite.
equal to yo over p minus r.
And if I look at the other triangle here,
So YI.
remember yi,
Q.
q is this distance here, and I want this distance here.
I got you. So it's,
I got
oh,
theta
okay,
too.
so it's q minus r?
Q minus r. And then there's a negative sign in there because in terms of the triangle, the tangent of, that's a angle less than 90 degrees, tangent better be a positive number, so we have to throw a negative in there to offset our negative value there. All right, so from this, if I get yi over y0, yi over y0, so I'm bringing the y0 down, the q minus r goes up, so that's going to be negative q minus r over p minus r. And now I can equate these two. I have two different relationships here, yi to y0, yi to y0. So if I therefore make this equal to that, and then solve and see what comes out of it. And it's something that actually comes out a whole lot simpler than having to go through this every single time. It's one of the reasons we're going through this. So q over p is equal to q minus r over p minus r. And I'm gonna do a quick check just to make sure I haven't screwed up a minus sign here. As sometimes I am wont to do.
Is that bottom one say P minus R?
That bottom one, yeah, that is p minus r.
No, I was talking about the P.
Oh, there is a mistake here. Fortunately, it's a small one. This distance here is not q minus r. The distance is r minus q. So that changes r minus q, r minus q, and r minus q.
So that would be, because it's, was that negative? So we are.
Well, I when I equated them, they both had a negative sign, so I just got rid of the negatives at that point. I could have.
R plus q?
Sorry?
Would be r plus q then?
It would be negative r plus q if we distributed the minus sign there. But I didn't feel a need to, since I was gonna get rid of the negative anyway in the next step. All right, so now I'm gonna cross multiply here, so q times p minus r. Q, and I probably should write my q's more neatly so they don't look like p's at all. Q times p minus r is equal to r minus q times p. I'm gonna distribute QP minus QR is equal to PR minus QP. Because I know how I want the formula to end up, I'm gonna bring my QP over to the left-hand side, and I'm gonna bring my QR over to the right-hand side. So what I'm left with is, on the left-hand side, 2 QP equals PR plus QR. We're not in the final form yet because it doesn't necessarily look simpler. Well, it is simpler than having to do all that, but I'm now going to divide by QRP or QPR, or, you know, the letters in some order. You got to divide each thing by it. It's just QRP, P, QRP. And so over here on the left-hand side, my Q's and P's cancel out, and I'm left with 2 over R. Over here, my P and R will cancel out, so I'm left with 1 over Q. And then over here, my Q and R will cancel out, I'm left with 1 over P. We have one more simplification to do. But we're going to use this formula. Any questions before I erase this part right here?
Where did you get the 2 from?
It's 2.
Because when I added QP to both sides, I then had 2 of them.
Okay.
Other questions? So if I have my mirror here, my concave mirror, so in reality it curved like that. So I got my concave mirror. And I got an object that is really far away. So imagine the sun. In other words, P is huge. Huge number. Because in the lab, we're going to be dealing with P's and Q's in terms of centimeters, but now, or even meters, but we're talking, you know, distance to the sun kind of thing. So if P is huge, what is 1 over P?
Small.
So my formula basically comes down to 2 over R is pretty much equal to 1 over Q. Or Q is equal to R over 2. My radius of curvature divided by 2. So if I've got these sun rays coming in like this, coming in straight, they're going to hit the mirror and they're going to bounce. And they're going to go through some point, which is basically half the radius of curvature. This is known as the focal point. And the distance from the focal point to the center of the mirror is typically labeled with the letter F. It's the focal length of the mirror. So F equals focal length, which is 1/2 the radius of curvature of the mirror. So my formula in its final form, 1 over the focal length is equal to 1 over the distance from the object to the mirror plus 1 over the distance from the mirror to the image. So 1 over F equals 1 over P plus 1 over Q. Or I guess typically written 1 over P plus 1 over Q equals 1 over F. And our magnification is negative Q over P. this formula here, actually these two formulas, the 1/over formula and then the magnification formula, actually applies to thin lenses as well as mirrors.
Are those two at the top the same thing?
They are, typically the P and Q go on the left-hand side, so that's why I'm more likely write it like this in the future. All right, questions before we actually do a problem?
So R is the distance from the intersection of the,
R is the distance from the mirror to the radius, to the center of curvature.
okay, so it's the distance from the center of curvature?
To the mirror. If we look at a physical mirror that's curved, so if I have a mirror that's curved here, the radius of curvature the distance from here to any point on the mirror, assuming it's part of this, it's a spherical mirror, is the same. This distance here is R, this distance here is R, the distance here is R.
Oh, okay.
Any light that goes through that point right there, heading towards the mirror, is gonna bounce right back through that exact same point. Feel like there's a follow-up question? Well, you have that one.
So it doesn't matter how far the object is.
The radius, this value of R is dependent upon the mirror itself, not the object.
Okay, so like, if an object is like a mile away, it would still show up in the mirror.
In theory, yeah.
Yeah. But the R value is when any part of the mirror is the same distance away from the object.
The R value is completely dependent upon what mirror you're using. It has nothing to do with where the object is at all.
What is that little thing above the R, what you just drew? That, yeah,
That is left over from
okay.
what was there before.
I just wanna make sure I haven't missed nothing.
So if I have an image that's over here, or an object that's over here,
Yeah.
any light that passes across that head and then goes through that center, goes through that point right there, is gonna bounce back along the exact same line.
Oh, okay, yeah.
But if the mirror is perfectly flat, and it bounces off at an angle,
Alright, so if the mirror is perfectly flat, what is the radius of curvature?
That'd be like 90 degrees. No, it's flat.
If it's flat, think about at what point, so if it's flat, because remember I can find the radius of curvature just by sort of thinking, like hitting it and bouncing directly back. Where do those beams meet if it's perfectly flat?
They don't.
So mathematically, what do we throw in there?
Infinity.
And so then my formula, so if R is infinite, what's my focal length?
The focal length is also infinite.
So therefore, I get 1/infinity, which is 0. So 1 plus P plus 1 plus 1/Q is equal to 0. And so P actually ends up being negative Q. We haven't really talked about what a negative there means, but. So if it's a flat mirror, then basically you're gonna get an image. So whatever distance I am away, the image is going to be basically the same distance away. The negative tells me it's gonna be a fake image.
Is light,
Virtual is the better word.
is the light section of this course a lot harder than the sound section of this course?
Depends on the way your mind thinks.
That's already seems way more complicated.
Let's do a problem.
That
We'll start out with a simple problem.
That might help.
Yeah, okay, I'm still kinda not really getting well, let's do a problem, so.
All right.
Kinda help me.
So if I have a mirror, concave mirror, so the focal length is, we'll make it 10 centimeters. Now, one thing I just want to point out here, the fact that it's a concave mirror, the fact that the focal length is positive, those go hand in hand. If it's a concave mirror, the focal length is positive. If the focal length is positive, and it's a mirror, it's concave.
But if it's negative, you got a problem somewhere.
It's convex. We can deal with it, same formula.
That just means it's gonna be this way, lights in
Yep.
here, lights in that way.
Yeah, so when light hits it, light's gonna go scattering back outwards, away from it, away from the center. All right. I have an object. Just say 15 centimeters from the mirror. And object is 2 centimeters tall. So a typical question is, where's the image? What's the nature of the image? What's the size of the image? I think nature is the term that the book uses. In other words, is the image inverted or upright? We assume that the object itself is upright. And I'm also going to typically, and I don't know why textbooks do this, but typically they have the mirror facing the other way from the way I did my derivation. So there's my object. There is my focal length, so that distance there is, I think I said 10 centimeters. This distance here is 15 centimeters. So doing the plug and chug first, and then we'll talk about trying to actually see if we can do this with drawing it. So I have 1 over P plus 1 over Q equals 1 over F. 1 over 15 plus 1 over Q is equal to 1 over 10. Now I didn't write units in here because I know they're both, my focal length and my distance of the object are both in centimeters, so I know Q is going to be in centimeters. But this is the math problem we're dealing with. So let's get this over, trying to solve for Q. So I have 1 over Q is 1/10 minus 1/15. Which is, the common denominator would be 30. Okay, so that's 3/10 minus 3/30 minus 2/30.
Equal 1/30.
So Q is equal to 30 centimeters. So this tells me that the light's going to hit the mirror and the image is going to show up farther from the mirror than the object was. Nothing wrong with that.
And you can solve one of these with just that F or R value, just one.
Right.
If F equals 1/2 R.
Yes, yes. And sometimes I will just tell you R and I won't tell you F and let you figure it out.
So F is always 1/2 more?
Yep. there, but yeah, we'll just that out. I was wondering, if radius of curvature is always a positive number, but I don't think I've seen a negative radius of curvature, but that doesn't mean it, because it usually,
And
this,
then concave.
right. So concave, positive, definitely, convex, focal length is definitely negative. I don't think I've ever seen a negative radius curvature, and I don't know if that's standard practice or, but usually at this point, you're given focal length and not given the radius curvature. All right, so if I drew this a little bit closer to reality, or closer to some standard. There's a wheel there. Is that relatively level?
No,
No,
Which way, up or down?
Right
your
hand
left.
down.
right hand down,
Yeah.
little more,
More.
little more,
Alright, there you
right
Yeah.
there.
go. Not bad.
Well, hopefully it's gonna fall into the category of close enough.
Yeah, close enough, yeah.
And I'm gonna put my mirror there. And my focal length is 10 centimeters away. So there's my focal point right there. And my object was 15 centimeters away. And 2 centimeters tall. That is really small. All right, so there's my object. So I know that light that comes in straight is gonna hit the mirror and then bounce through the focal point. So light that's coming in straight across here hits the top of that image. It's gonna go through my focal point right there.